In this second presentation, we will continue discussing the tomato fruit shape traits. In this slide, I am showing an image of a segregating population developed by Andrea Mazzucato from Unitus that is being submitted to farmer selection in the framework of the Work Package 8 of the HARNESSTOM. This image shows a huge diversity of fruit shape and color traits, but we can have the feeling that something is missing, that the diversity is flat. This is because there is very little diversity in the traits we will discuss in this presentation. It is for this reason that the following characteristics of the fruit are very important when describing the external appearance of the tomato. These are ribbing at the peduncle end, depression at the peduncle end, size of the peduncle scar, size of the blossom scar, and shape at the blossom end. Finally, we have one trait that is related to the internal appearance: the diameter of the core in the cross-section. Let's look one by one. Ribbing is a key trait that defines the external fruit's appearance. It refers to the presence of longitudinal slits in the fruit from the calyx, as it is shown in this picture from CPVO. It is usually measured on a qualitative scale, from absent to very strong. It is a trait very difficult to measure using image analysis, so for the moment this is the most suitable measurement scale. Fruit ribbing is very present in all land races, but this trait kind of disappeared in modern varieties. Nowadays, fruit ribbing is being recovered by breeders, and we can find many new varieties that present ribbed fruits, as a claim to ancient taste. In this second slide, you can see more images showing fruits without or with very strong ribbing. And more. These are fruits from land races grown in Catalonia, where the ribbed fruits were highly appreciated anciently. In fact, fruit ribbing was one of the key traits distinguishing important land races such as Montserrat or Percheron. That's why in my region we are used to this trait. A second trait very important that determines the fruit's external and internal appearance is the depression at the peduncle end. It refers to the indentation present in the region of the calyx, which is mostly present in big fruits. The qualitative scale shown in the figure is widely used in routine tomato phenotyping, but currently there are image analysis tools that allow more accurate phenotyping of this character, such as the tomato analyzer. In this slide, I show you an example of fruits that increase in the depression at the peduncle end. You can see the big effect that this trait has on fruit appearance. Stem scar is an important structure in the tomato fruit, playing a key role in gas exchange between the fruit and the atmosphere. As Nadia Bertin and collaborators describe, the atmosphere within a tomato fruit is isolated from the surrounding atmosphere by the impermeable skin and cuticle. About 95% of gas exchange occurs throughout the stem scar. Another important aspect is that the stem scar is an entry point that allows opportunist microorganisms to penetrate and affect the fruits, as it is, for example, for Alternaria or Botrytis. This is a trait not usually considered in phenotyping kits because of the difficulty in standardizing the measurement. According to CPVO, the size of the peduncle scar should be observed as an absolute characteristic, irrespective of the fruit size. The scar can be classified on a scale from very small to very large. Moreover, also according to the CPVO trait description, the size of the peduncle scar refers to the green ring observed when removing the peduncle from the fruit, and not to the full scar. You can observe the difference between the green ring and the full scar in the two fruits at the right of the slide. The black line shows you the full scar, whereas the yellow line shows you the green ring. The blossom end scar, located opposite the stem end of a fruit, also known as the stellar scar, serves also as an entry point for various pathogens. Despite its significance, it has been relatively understudied in comparison to other plant traits. Two different physiological disorders are associated with the blossom end scar, such as the blossom end rot or the corky stellar scar. As was proposed by the previous trait, CPVO proposes a qualitative classification from very small to very large, which should be observed as an absolute characteristic. This is irrespective of the fruit size. A key trait in the external appearance is the shape at the blossom end, which can range from indented, flat, to pointed. As we have seen previously, blossom end morphology is controlled by genes controlling the nipple-like protuberance or the persistent style trait. This is when styles remain attached to the ovary, resulting in the so-called beaked or lemon-shaped fruits. Low night temperatures can increase the presence of these beaked fruits. For observing this trait, we should look at the blossom end of the fruit in the longitudinal section and classify the morphology according to the scale provided by CPVO. Finally, the diameter of the core in the transversal section is a key trait that impacts internal appearance. For measuring this trait, we should compare the diameter of the core with the width of the fruit. Fruits can be classified on a scale from very small cores to very large. Usually, fruits with a high number of locules tend to have a higher proportion of core with respect to the width of the fruit. Again, as we discussed in the first part of the fruit-shaped traits, the tomato analyzer provides very useful tools to characterize, in a quantitative manner, some of the traits that we have presented in the previous slides. You can see in this diagram the list of traits that are automatically calculated by the tomato analyzer, which are the depression at the peduncle end, referred to as proximal indentation area, and the shape at the blossom end, referred to as distal indentation area and distal end protrusion. Unfortunately, for the ribbing at the peduncle end, the size of the peduncle and blossom scars, and the diameter of the core in cross-section, we still need to use manual measures to phenotype these traits quantitatively. So, that's all on my part. I would like to thank the Maritza Vegetable Crops Research Institute for the organization, the HARNESSTOM project, and the Roxy Cost Action for supporting this training course. Thank you for your attention and enjoy the presentations.